In this month's Mastertech session, we're going to talk about multiplex electronics and body chassis diagnosis on the 1988 Chrysler New Yorker, New Yorker Landau, and Dodge Dynasty. Multiplex electronics may sound complex, but the fact is you've probably used many devices that depend on multiplexing every day. Take the telephone, for example. You probably built one of these when you were a kid. And you probably realize that one big disadvantage of the tin can telephone is that it can only connect you with one other party. To talk to everybody in this phone book, you need a lot of cans and a lot of string. But with this single telephone, which has just one line connected to it, I can call anyone in this book. In fact, almost any telephone in the world. This is possible without having to hardwire every telephone in the system to every other telephone in the system. Instead, the telephone company uses electronic multiplexing, the technique of transmitting two or more signals on a single set of wires. The same technique is used in stereo radios to allow transmission of the sound for both the left and right speakers on one channel. In this personal computer, electronic multiplexing helps increase efficiency. As this simplified example shows, without multiplexing, each individual component must be hardwired to every other component. This design can be inefficient and expensive to build and operate. By using multiplexing, the individual components can share data, which is transmitted on a device known as a data bus. Each component connected to the bus is called a node and has the ability to access the data that is on the bus as it is needed. Like the telephone, the stereo radio, and the personal computer, the electronic multiplex system used by Chrysler on some 1988 vehicles offers increased efficiency. Multiplexing eliminates the need for some hard wiring in the car and reduces the number of wires going to the bulkhead. It also eliminates the need for two or more sensors that do the same thing. For example, in a system equipped with automatic door locks, the signal from the distance sensor is used by both the premium body computer, which automatically locks the doors at 15 miles an hour, and the single module engine controller, or SMEC, which uses vehicle speed in a number of calculations. With multiplexing, these two modules can share the vehicle's speed information, even though the body computer is not hardwired to the sensor. Multiplexing has also expanded the onboard diagnostics and made it possible to use the DRB II when diagnosing body electrical problems. Before we talk about diagnosis and service, let's take a little closer look at how Chrysler uses multiplexing in automotive electronics. Just as in the personal computer, the system components are connected to a common data bus. To reduce electrical interference, twisted pairs of wires are used. One thing that can be confusing is the name of the system, the Chrysler Collision Detection System, or C²D system. This doesn't refer to car crashes. It has to do with the system's ability to prevent data collisions. Because the nodes or components on the data bus can send information at any time, there has to be a method of organizing the data. Each block of data has its own unique ID, known as an address. At each node, a special microcomputer chip scans the bus. If two nodes try to transmit data at exactly the same time, the C²D system will detect this, and the most important information will be sent first. The same thing happens if more than two nodes try to transmit at the same time. The most important data, as indicated by its address, will be transmitted to the bus first. The C²D system acts like a busy executive secretary. It screens data going to the bus in the same way a secretary screens the boss's telephone calls. At any one time, only the most important ones can get through. One more important feature of the Chrysler C2D system is that the DRB II can now be used to diagnose body electrical conditions. When the DRB II is connected to the data bus through the diagnostic connector in the car, it acts like a node on the system. It can send and receive data just like the other components. We'll cover more on diagnosis of the system in a minute. Right now, the most important thing to remember about what we've already covered is that you don't have to understand multiplexing to work on the system, just as you don't have to understand multiplexing to use or even to fix a stereo radio, a personal computer, or a telephone. With that in mind, let's look at the multiplex systems used on Chrysler cars so you can diagnose and service them. The C2D system is currently used in the 1988 Dodge Dynasty, the 1988 Chrysler New Yorker, and the 1988 Chrysler New Yorker Landau. 3 different systems are used: the Electronic Vehicle Information Center, or EVIC, the Traveler system, and the base system. Each of these systems has some components that may be new to you, so let's see where they're located on the vehicle. This 1988 New Yorker Landau is equipped with the Electronic Vehicle Information Center, or EVIC, and the Automatic Air Load Leveling System. The major components of these 2 systems are shown in this diagram. EVIC components include the premium body computer, which is located here behind the passenger side kick panel, the overhead console, also called the EVIC head, the engine node, which includes the electronic compass, the single module engine controller, or SMEC, and finally, the lamp outage module, which is located here. The lamp outage module senses headlamp, tail lamp, or brake lamp outage and is hardwired to the premium body computer. The other components we've identified all communicate through a multiplex system consisting of twisted wire pairs attached to each module. The possible EVIC messages are shown in this chart from the 1988 Body Chassis Diagnostic Test Procedures Manual. The Traveler system has this Traveler module instead of an overhead console. It has the same premium body computer and SMEC as the EVIC system. The base system has this incandescent message center instead of an overhead console or Traveler. It also has the same SMEC, but instead of the premium body computer, it has a base body computer. This control module for the automatic air load leveling suspension system is located here in the trunk. The other major components of the system include the compressor relay, the compressor assembly, which includes the air exhaust solenoid, and the right air shock, which has this height sensor built into it. Incidentally, the control module limits compressor pump operation to about 150 seconds during diagnosis. This prevents damage to a normal system. During operation, however, the system usually operates for much shorter periods. When testing the system, however, it's possible to cause damage by operating the compressor for prolonged periods, so use caution. Well, that about covers the theory of operation and component locations of Chrysler's body and chassis electronics. Now, let's go to the shop, where Mike will cover some of the diagnostic and service procedures on these new systems.
Onboard diagnostics on this 1988 New Yorker Landau can make your job easier if you know how to use them. This car, as well as the 1988 Dodge Dynasty and the 1988 New Yorker, all feature body and chassis electronics that can be tested with the new DRB II tester. Of course, your own knowledge and good diagnostic sense will help too. The 6-step electrical troubleshooting procedure outlined in the November 1987 Mastertech release, will work as well with these systems as it will with any other electrical or electronic condition. In fact, you might want to take time to review the videotape from that session. And if you're not familiar with the DRB II tester, it might be a good idea to also review the current service information segment of the October 1987 Mastertech videotape. It shows the procedure for using the DRB II when diagnosing engine conditions, and it will help you get acquainted with its use. To perform any required service operations on either system, you'll also need a copy of the 1988 front-wheel drive service manual. Finally, you'll need the 1988 body chassis diagnostic test procedures. Along with your own common sense and the DRB II, this manual will help you solve even tough diagnostic problems with a step-by-step approach. The manual is divided into body and chassis tests, and there's a separate body test for each system: base, traveler, and premium EVIC. You'll find some logical guidelines that must be followed when using this procedure. For example, always start with test 1 in the proper category and perform only the action required for each test. Performing other actions might make your test results invalid. Also, don't forget to restore the system at the end of each test. Leaving things jumped or disconnected could affect later test results. Always make sure the car has a fully charged battery before you begin testing. Whenever the procedure tells you to probe the SMEC 60-way connector, always probe from the terminal side. Probing from the wire side may give you bad test results and may even cause damage or component failure. Also be careful not to ground, short, or energize any of the terminals when testing. This could damage the SMEC. Using a test light might also cause component damage, and it won't provide you with useful information anyway. The procedure will sometimes instruct you to use a digital volt-ohm meter to check resistance. Before you do so, remember to determine the built-in resistance of the meter. You can do this by simply touching the leads together. Then note the reading. This is the built-in resistance of the meter. To get a true resistance reading, you have to subtract this resistance from your test reading. For example, if you check a component and get a reading of 1.1 ohms, you just subtract the built-in resistance of 0.3 ohms to get the actual resistance of 0.8 ohms. Finally, don't forget to re-evaluate the system after a repair has been made. You should recognize this as the final step in the 6-step troubleshooting procedure. We're going to cover it right now, however, because it's one thing that this little box can really help you with. The DRB II performs a number of test functions, including a system check that will save you a lot of time. First, insert the software cartridge. This C2D adapter cable connects the DRB II to the vehicle. It plugs into the interface cable of the DRB II and then into the diagnostic connector under the instrument panel. The DRB II will go directly to the self-test function. All the display segments should turn on, the green and red lamps will light, and you should hear a beep. And that's all there is to it. You don't have to do anything else. In fact, don't touch the keypad during the self-test. If there is any problem, the DRB II display will read hardware failure. If this happens, refer to the tester instructions. After the copyright display, you'll see this display, which asks you to select a model year. To make a selection on the DRB II, just press F1 or F2 to toggle through the choices. Now I have the correct choice on the display. I'm testing a 1988 model car, so I press yes to enter my choice. The rest of the choices are made in the same way. For example, the next message will ask you to select a system. The initial choice is powertrain, but I want body systems. So I just press F1 or F2 until body systems comes up on the display. And then press yes. Then you'll see this message. The DRB II is ready to perform body diagnostics. Turn the ignition on, then press yes again on the DRB II. The tester will perform an automatic bus test and an automatic module check. If it finds no problems, the next display will ask you to select the module. For our demonstration, I'm going to select the EVIC head. Incidentally, the DRB II knows which module the car is equipped with and can tell the difference between a premium body computer and a base body computer. If you try to select a module that is not on the car, for example, if you selected a Traveler on a base system, the DRB II display will read no response. All right, now that I've selected a module to test, the EVIC head, I have a choice of test modes. The DRB II can be used to read fault codes, to perform a switch test, to perform a sensor test, or to perform an actuator test, which is going to be my choice. This is the actuator test for the EVIC head. All display segments should be illuminated. Well, that covers the basics of hooking up the DRB II and using it for system checks. You'll find more information in the 1988 Body Chassis Diagnostic Test Procedures Manual. Now let's see how the DRB II can be used to diagnose some typical body and chassis conditions. This is a fairly straightforward customer complaint. There's a low coolant level warning on the message center, but the coolant level is okay. The first step is to verify the customer complaint. That's easy enough. While I'm at it, I can also check for any related symptoms. Well, I haven't found any other problems, but the display is showing a low coolant level. A check of the coolant level shows that it's okay. Our next two steps will be to analyze the symptom that we've just verified and to identify the cause of the problem. The DRB II and the Body Chassis Diagnostic Test Procedure will help us do that. This car is equipped with a premium EVIC system, so I'll use that procedure and start with the preliminary checks. The first few steps in the procedure have led me to this point. The procedure instructs me to connect the DRB II to the body connector and turn the ignition to the on position. Then I just toggle through the choices and select the coolant level switch function on the DRB II. The display reads coolant level switch closed. So the procedure directs me to step C of test E20. This step tells me to check the coolant level. I already did that, and I know it's okay. So the procedure then tells me to go to step D of test E20. With the DRB II connected and the ignition on, I disconnect the coolant connector and check the display on the DRB II. It reads coolant level switch closed, engine node. According to the procedure, this means that the problem is a short to ground in wire N18 going to the coolant level switch. Here's the problem. With the help of the Body Chassis Diagnostic Test Procedure and the DRB II, I've isolated the cause of the complaint. After making the repair, I can quickly verify the fix and check the system as outlined in the test procedure manual. This is always an important step, especially when you're dealing with the kind of customer that owns a car like this. He doesn't want to be back in a couple of days with another complaint. Well, everything checks out okay. Now let's look at an example of how you can use the DRB II to diagnose a problem with a chassis condition. Well, this looks like a tricky one to diagnose. The customer complaint isn't very specific. The RO describes it as an uneven ride. The service advisor couldn't get the customer to relate it to any one type of driving. And it's an intermittent fault, the toughest kind to diagnose. With a complaint like this, it might be a good idea to check with the service advisor and make sure that the customer understands the normal operation of the automatic load leveling suspension system. Assuming that the complaint is real, I'm going to go ahead and check the system. Verifying an intermittent complaint is always difficult, but by using the DRB II and following the Body Chassis Diagnostic Test Procedures, I can perform a system check. That should help me verify the complaint and any related symptoms. And if I do find a real problem, following the procedure should also help me analyze the symptoms and isolate the trouble. In other words, I can go through the first 4 steps of the 6-step troubleshooting procedure. Diagnosis of the chassis system begins with a brief visual inspection that includes checking the system's electrical and pressure line connections. After making a visual inspection and removing the necessary trim to reach the load leveler diagnostic connector, I can connect the DRB II and perform the load leveler test. Once the DRB II has passed the automatic self-test, I just toggle through the choices, selecting chassis systems, load leveler module, and actuator test mode. The DRB II display now tells me to turn the ignition on to start the diagnostic procedure. After turning the ignition on, I sit on the right edge of the rear deck to provide the necessary weight. Then I just press yes on the DRB II keypad and check the display. This is the display reading. It indicates an error from a previous test, but we didn't perform any previous test. So, according to the test procedure, we should go to test C5, step A. This test checks the load leveling module. With the ignition off and the DRB II disconnected, I connect a jumper wire from a good ground to the LL1 wire in the black 8-way connector. I then reconnect the DRB II. Then I repeat the actuator test. Okay, Bob, turn it on. Okay, shut it off. The point here is only to see if the compressor is actuated. Don't let it run for more than 7 seconds, or you could cause damage. Now the procedure sends us to test C5, step B. This will determine if the cause of the problem is either an open in the circuit between the 8-way connector and the shock absorber, or a faulty sensor. All right, there's no open. The ohmmeter shows continuity, so the problem isn't an open circuit. So the shock absorber sensor itself must be faulty. I'll have to replace the shock absorber and then use the DRB II to run a system check and verify the repair.
That completes this month's session. We've covered a lot of ground, from the theory of multiplex electronics to body and chassis diagnosis with the DRB II tester. You'll find more diagnostic information in the 1988 Body Chassis Diagnostic Test Procedures Manual. Using the tester, the procedure in the manual, the 6-step troubleshooting procedure, and your own knowledge, you should be able to handle diagnosis of any problem with these new systems. We'll see you next month.